Alright, so there are your solutions. You can pull up the key if you want to see the process on those. Just make sure you're getting everything into the same base there before you solve. And on to logarithms. Whenever we see a logarithm, say to yourself, to what exponent do I raise? For example, to what exponent do I raise 9 in order to get 81? I don't know where my log base 9 went there, but if that happened on yours, here's what this should be. So for what, that's what should be there in that blank. So log base 9 of 81, really just think of it as a question. 9 to what power gives me 81? And it would be 9 squared. So that question mark actually can turn into a 2. All right, let's do some problems that are actually on the paper for you. Sorry about that. So 5 to what power gives me 625? And I like to rewrite it. 5 to the x equals 625. And that is 5 to the 4th. Here, 2 to what power gives me 1 over 8. So 1 over 8 we can do two things with. One is flip it up. When I flip that up, I'm going to make the exponent negative. And then 8 is 2 to the 3rd. So I can change that 8 to 2 to the 3rd. And then there is your multiply. So 2 to the negative 3rd gives you 1 over 8. Last one here, 144 to some power is 12. Well, 144 is 12 squared. So here, 2x equals 1. X is 1/2. 144 to the 1/2 is 12. Power to the 1/2 is the same as square root, so that's lovely. All right, here it says, let's consider 10 to the 3rd equals 1,000. We can say that 3 is the exponent on 10 that gives us 1,000, or log base 10 of 1,000 equals 30. And here we have a couple more we can try. So we just want to change these around. 9 to the 3rd equals 729. Again, I like making myself a fill in the blank whenever I can. So 9 is my base. 3 is my exponent. And 729 is what we're equal to. Make yourself a fill in the blank. All right. My base is 6. My exponent is 4. And I'm working with 1,296. On my paper, I have 13 to the 0 equals 1. I don't know if you have that one. Apparently some of my equations moved around a little bit, which is frustrating. So here, if you don't have that one, you can have it. My base here is 13. My exponent is 0. And I'm taking a log of 1. Log base 13 of 1 equals 0. The rest of this page is just working these back and forth, exponential form to logarithmic form. So if you feel good about those first couple, fly through it. If you feel like you need more explanation, keep watching. I'm going to keep working. So here, I'm just going to do all of the ones that are exponential to logarithmic form. And it looks like I'm missing 1 or 2 here too. So let me fill those in for you. I am missing this guy. This should have been on your paper. Sorry if it got moved. Okay, I think we're good otherwise. All right, now we can roll. So b to the 5th equals 32. So b is our base, 5 is our exponent, 32 is what we would be taking the log base b of. Let's go ahead and do these others, the 6 to the 3rd and the g to the r. Again, just making these, fill in the blanks for myself. For 6 to the 3rd, the base is 6, the exponent is 3, and y is what we're taking the log of. For g to the r, the base is g, the exponent is r, and taking the log of m. And now let's go logarithmic to exponential. This is the direction that I think is a little easier. The x is my base, 3 is my exponent, 64 is what we're equal to. This last one, b is my base, x is my exponent, and we're equal to t. When we get to the point where we're doing a lot of these in class, I'll write it out for you as clearly as possible, but the more fluent you can get with this, the quicker you can get, the more confident, the better. All right, now we're going to evaluate. We're going to do some evaluations without using our calculator. So I like to set these equal to x. You can set it equal to y or z or a or smiley face or heart. It doesn't really matter. They're just variables. So here I'm going to do 4 to the x is equal to 64. And then I'm going to switch that up. 64 is, let's see, 64 is 16 times 4. And 16 is 2 4s. So 64 is 4 to the 3rd. So here our x equals 3. Great. 2 is a base that we use a lot. It's nice and simple. 2 to the x equals 1 over 16. Again here, base, exponent, what we're equal to. I'm going to bring 16 up, so that means my exponent needs to be negative. I'm going to make it base 2, so 16 is 2 to the 4th. If you need that in 2 steps, that would be 16 to the negative 1, and then change it to 2 to the 4th. So here we have x equals negative 4. You can absolutely check these on your calculator right now. However, your calculator will not be available for this unit test. All right, log base 1/3 of 27. So my base is 1/3. So some exponent equals 27. When I see 1/3 of 27, I know I'm going to want base 3. So I'm going to flip this up. That means I need a negative exponent. 27 is 3 to the 3rd power. And now I can drop my bases. Negative x equals 3, which means x equals negative 3. Or that whole thing equals negative 3. Log base 1/3 of 27 is equal to negative 3. That's your answer. So don't get caught up in the fact that these all say x equals. This is really log base 4 of 64 is 3. 4 to the 3rd is 64. Log base 2 of 1 over 16 is negative 4. You can absolutely replace those. If you saw log base 2 of 16 in a problem, you could plop negative 4 in there and replace it and make it much nicer. All right, a couple more questions here, a couple more problems. 7 to what power gives us 1? Well, anything to the 0 is 1. So what I just wrote there is 7 to the 0 power is 1. Okay, 32 to some power is 2. I'm going to use x here. 32 to the x equals 2. 32, if you need a factor tree for that guy, is 2 to the 5th. So I have 2 to the 5x equals 2 to the 1st. So 5x equals 1. X equals 1/5. So that means log base 32 of 2 is equal to 1/5. 49 to some power equals 7. If you can do that in your head and say, well, that has to be 1/2. The square root of 49 is 7. That's lovely. If you need to do the steps to get there, that's no big deal either. 49 to some power gives us 7. 49 is 7 squared. Hopefully this little review has been helpful if you needed it. If you have additional questions, please let me know.